Hello, assalamu alaikum guys. So yesterday, no, means it was yesterday. You can say, or in a previous topic, we also discussed how electron was discovered. But now today we'll also be discussing how electron was discovered by another scientist named as William Kroc, and how proton was discovered. Okay, so let's begin. So, by electrolysis, will also means will be proving this discovery, and another scientist whose name is William Kroc. He's I think second scientist who proved the discovery of electron, and Goldstein, who discovered proton. Um, Basically, Goldstone doesn't did anything, but he used his common sense to discover the proton, and it's fine. Okay, now passing the current through low pressure gas. So we'll be using here and discharge tube. Okay, 1 minute. Let's read this line first. Name of the instrument. What is the name of instrument? Discharge tube, or we can also discharge tube. Okay, sorry. Next is Kessler tube or Crookes tube. So these all are the name of this, just a little tube. Okay, so let's start. I think simply we can start the process. So what is this? This is a suction pipe, means from here will be means decreasing or increasing the gas. Okay, inside there is a gas name as H2. Okay, so for example there is a gas. Now just will be means this is a cathode plate. Okay, and this is the anode plate. After that there's a means in the end of this there's a zinc sulfide. Just I think this is for like if the charges will be coming from another side to this side, so if there is a glass tube, so they will go away. They'll not means they'll not be clue. We don't have any proof if we means not put zinc sulfide here, so the electrons will run away. But that's why we put zinc sulfide here. Okay, there's a cathode and there's an anode. How much voltage we need? 10,000. And also we need pressure 0.01 mm of Hg. It's I think unit of pressure. Okay, so let's begin, or let's start. So here when we just means give the electricity, from here negative charges are going, means anions are going, and from here cations are moving. Okay, when we just give the current of 10,000 volts, the H2O will be running. The H2O will be start coming. Sorry, I'm okay. Sorry. Not H2O, means the negative charges will be coming inside the tube, but they will not, because of the high pressure of H2. Because inside the pressure is much, means there are many H2O. So by the suction pump we simply take H2 out. Okay, for example we are just taking example, means there is a low we need low pressure. So for example we are taking two H2O molecules, means now there are only two H2O molecules remaining. So the negative charges which are there. Okay, now the electrons, means we don't know electrons, we just know there's something negative. Okay, so they are moving. Now when when the negative charge moves inside, so there's a means glow lighting effect. So the scientist William Crook was also confused. He was watching like he go down and watch there's a light. After that he put the stairs. It was a big, means it was a big machine. It was a big discharge tube, not small. So he put the stairs and watch. I'm joking. Okay, just he was watching, means how light is coming. After that he concluded that when negative charges are moving inside, when negative charges are moving inside of H2O, sorry H2, they collide, means they collide each other, and because of the collision the glowing effect is produced as like this. Negative negative, they both are coming inside discharge tube. For example, this is a discharge tube. Okay, after that H2O H2 sorry H2 H2, they collide, and because of the collision there was a flash appear. Okay, appearance, we can also say there was a glow. After that he watched this, he watched, and after that he means started to think, and he just did, you know what, he sucked more H2 outside, means he threw all the H2, just there was a one particle, means there were many, means in very much low quantity, like this was a quantity 0.01 of H3, means this was a pressure. After that, when, means we are just taking example that he take all the H2, only just one H2 is remaining. It's an example. There was a pressure very much low, okay, of H2O. Means what is pressure? Just means amount of H2 inside this tube. So in last we are using some solution in previous yesterday, but now we are using, you know what, gas H2. Okay, so after that, when he just means remove all H2, only one molecule remaining, so there was very low collision, and because of that, means collision has stopped. He thought there's nothing now, means first, at first he was thinking that something is coming from the cathode, some particles are coming, an unknown particle are coming and striking to H2, but after removing H2, he was saying nothing, there is nothing in cathode. But after some time, when he watched as zinc sulfide, so zinc sulfide suddenly start to glow, okay, glow disappears, like electrons are moving, there's just H, one molecule of H, and glow disappears. After that, when he means move electrons, there was this is a zinc sulfide, Z and S. Okay, zinc sulfide. So after negative particles are moving to zinc sulfide, and they were colliding. So because of that collision, there was also a light, a glowing effect was there, like flash would be appear inside the zinc sulfide. So simply he make the conclusion that the cathode, means from the cathode some negative charges are moving, and after that they are moving to positive sign, and because of this positive, there is a positive sign, so they are running to positive, and they are striking to zinc sulfide. So he's just said that cathode rays are striking, that what are striking, he named that the striking particles as cathode rays. Okay, and also before striking, he named cathode particles, means cathode particles are there, which are striking to the zinc sulfide, and after striking, there is a means effect which is known as cathode rays, he named. After that, I don't know, I am forgetting the scientist name who gave the name of electron. So hence now we have been proven that electron is discovered. The Goldstein. Now let's discuss how proton was discovered. So Goldstein, the corner, was watching his experiment, and William Crook was very much happy, and he was running. So it's just I'm joking, okay. So he was running and dancing. So when he means when he was gone. So Goldstein just did. Goldstein first watched what was going on in this tube. After that, he just make hole, in cathode side. He made holes here, means small dots. So he was means just making that there are hydrogen particles. Okay, hydrogen particles when the cathode means the negative. Okay, let's make here's an example. We are having two, means H2O, two molecules H2. Okay, two molecules of H. So we can also write this, means the one is having one proton and one is having one electron, both one proton plus one proton is equal to two proton and two electrons. So there are, for example, we are just taking example, there will be more hydrogen, means there will be in huge amount electron, the electron will be in huge amount and the proton will be also in huge amount. So just now take example that there are two proton, two electron and two molecules of H2O, not O, just H2. Okay, after that, when the negative signs were released from cathode, so the this is the hydrogen, means the table, so two electrons, so just the negative rays were, means making this band, oh sorry, this bond weak, like nucleotic force very weak, and because of this weakness of nucleotic force, also the negative charges were striking the electron, and because of that striking, the electrons were removed. Okay, so both electrons were removed from the hydrogen. So hydrogen, now hydrogen is just now ion, as we know, whenever an atom release is electron, it will be converted into ion, but when it releases electron, means it is converted into positive ion. So H now is like positive. So he also put I think zinc sulfate here also. So there are dots, now it's confirmed there are dots. So when the negative means negative means the cathode rays, or we can also say that electron were hitting H2 and H2 electrons were also removed, so H2 goes to the another, means anode side, and was, means attaching on zinc sulfate on right, means right side, sorry. Okay, after that there are now just H positive ions, as we have said here, H positive ions. So because of that H positive, they'll we know that it will means negative will attract positive and positive will attract negative. So because of that attraction, the H2O moves H2 sorry, not H2, H ions, means protons, just we can also say the proton, because there is no electron in that H plus, there is just proton. Okay, so as we know, hydrogen don't have any neutron. Okay, so just hydrogen or just proton, so they will be, means running to this side. Okay, to negative side. So there were holes, and because of that holes, the H2, means the proton were striking the positive the positive rays or particles were means striking on this zinc sulfide. So by this experiment, Goldstein just Goldstein just used his common sense to prove this proton, and William Crook also did very well to prove this means electron. But at first Faraday discovered, you know what, electron. Okay, I think you have now, means understanding this topic is clear to. Now will be, means meeting in the next lecture. So thanks for watching.